Hello everyone, welcome to this video. In the reasoning section, we are going to talk about the quantitative reasoning topic in this video. This video is brought to you by Learning Made Easy team, a team of IIM grads in association with the e-learning partner GTCUBE Get to the Top. If you are watching this video on the YouTube channel, make sure that you check out our full-length courses available for free at gtcube.com/store. We'll get to watch these videos as part of the course and also get to practice a lot of questions on these concepts that will help you understand them better. So let's get started. So quantitative reasoning is basically, reasoning questions which involves a lot of numbers and numerical logic, right? Like A holds twice as many chocolates as B, and then B holds half as many chocolates as C, and then how many chocolates does all three of them hold together if C has 7 chocolates or something, right? So things like that could be asked where you're dealing with the numbers, double, half, sum of them, product of them. You'll get clues where you have to just add some numbers, multiply some numbers, look at possibilities for the, so you'll have lot many variables, so it will not be like completely algebra. So just let's get to the same example I was talking about, right? A, B and C, right? So A has twice as many chocolates as B, so if B has X, then A has twice, 2X. C has half as many chocolates as B. Okay, let's assume that's the clue I said, and then I say the sum of the number of chocolates of A plus B plus C is 10. So this is a simple algebra question, right? So that is 2x plus x by 2 is 10. So there's only one equation, one variable, so that's good enough to solve, and that will give me the answer. Right? So I think this will be slightly give you a non-integral value which is not accepted, but still that's okay. So that's how you can do this question. Slightly in the reasoning section, you will not be able to write these many equations. Let's say I'll tell you something like this, okay? Like this. So C has some number of chocolates, I don't have any clue on that, and I know that A holds twice as many chocolates as B. So what will I end up with? I end up with this. So 3x plus y is 10. So this is what you'll see rather in the reasoning. And then I say that y holds odd number of chocolates. So if y holds odd number of chocolates, y can be 1. So what will be x? X will be 3. 3 is 9 plus 1. Or this could be 3. If y is 3, what is x going to be? 7 by 3, which is not accepted. Then y can be 5. Then x is 5 by 3, which is also not accepted. Why? Because b has to hold integral number of chocolates, right? He cannot have 5 by 3 chocolates. He has to have 5 chocolates, 2 chocolates, 3 chocolates. 7, yes. If y is 7, then x is 1, which is also accepted. If y is 9, then x is 1 by 3, which is also not accepted. So I see two possibilities, right? And let's say B holds more chocolates than C. So in that case, what is the only possible answer? This is the only possible answer. So that is how these quantitative reasoning questions will be framed. I have this purely on base of algebra. I cannot solve this because I have only one equation and 2 variables, so there will be multiple possibilities. But facts which will be used as clues is number 1, x and y have to be integers. Why? Because we're talking them being the number of chocolates. I cannot have half chocolate. Yes, you can have, but let's assume they are like, let's say marbles. Let's assume the question is based on marbles. I cannot have half marble. I'm bound to have 1 or 2 or integral values basically. Right, just understand it has to be integers is one clue. Then they have added another clue saying that C holds odd number of marbles or chocolates. That is another clue, right? So that means I won't count 2, 4, 6, 8, 10. So these are all out of scope. And then they're also saying the number of marbles or chocolates B holds is more than C. So clubbing all these clues, looking at the possibilities, and then deciding the answer is what you will generally do in the quantitative reasoning. Right, so let's get started with the questions to understand them better. So simply let's look at this. Ram gave his ATM card to me. He gave me following clues as well to crack his ATM pin. So the product of digits of the pin is 210. Okay. So the digits will be basically 0 to 9. Right, and it could be anything. It could be a pin like 111 or 1231, etc. But the clues are saying the product of digits of the pin is 210. So whatever the 4 digits are, they'll multiply to give me 210. So I don't know the individual values of A, B, C and D, but I know the product is 210, right? As I said, there's only one equation with 4 variables, so it is not sufficient enough to answer. And there's one more clue which says there are 4 digits. So yeah, I have used this clue as well, that there are 4 digits. That's why we have taken A, B, C, D, and they are arranged in the increasing order. So again, I would not be, I could not, or I cannot solve the question based on just the given clues. So what will I do? I'll try to factorize this. That is, get them as multiples of 4 digits. So 210, right? 3 into 70, 7 into 10, and this is 5 into 2. So this looks like a good example. So I have 3 into 7 into 5 into 2 is 210. So that 4 digits are 3, 7, 5 and 2. And then it is saying arranged in the increasing order. So the pin should be 2, 3, 5 and 7. Is this the only pin that you can get satisfying the given clues? Sorry. Not really. How? What is the other possibility? So 210 can also be written as 7 into 5 into 6, 35, 6 5 is 30, 37 is 210. So that's okay, but that is only 3 digits. What is the 4th digit? Into 1, right? I can also have something like 7 into 5 into 6 into 1. So what will I get? 1, 5, 6, 7. This is also another possibility. Can I do anything else? Is there anything else possible? 6 can be split into 3 into 2. That's fine. So that's why I got this. 3, 2, 5, 7. These are 4 prime numbers. I cannot split them further, right? If I do 3 7s is 21, 3 5s are 51, 3 2s are 6 is, that's why I wrote them into 7 into 5 into 6. Any other two numbers, if I club and try to get a new digit, it will be greater than 9. It won't be a digit, it will be a 2-digit number, right? So these are the only two possibilities. 7 3s are 21, 7 5 are 35, 7 2s are 14. All of them, multiply them, right? Only 3 to the 6 will give me. So 7 into 5 into 6 is what I'll get. So the 4th raise will be simply into 1. So because the product, anything multiplied by 1 is the same number. So that's why we are using that rule to get 7, 5, 6 and 1 as the another, possible 4-digit pin. So I see 2 pins here. So what would be the minimum number of attempts required to get is correct ATM pin? That will be 2. Right? I can also get one attempt, but then what if I don't know? Let's say this is the pin and I attempt this. So that won't guarantee, right? So that is basically luck. So if I have 2 attempts, I can definitely get the pin. I'll get this or this as the correct pin based on how I enter it, right? So that's why the answer would be 2. Slightly bigger story. There are 4 sisters in a family. Let's call them A, B, C and D. They have an agreement that they will share chocolates equally among themselves if they give them as a gift. One day their aunt brought chocolates for them and gave it to Amy. Since there were no one around Amy, she divided the chocolates into 4 equal parts. So she divided them into 4 equal parts as per the earlier agreement, and then she ate her share. Now she put the remaining chocolates, that's the 3 parts that she is kept for her sisters, back into the box. Then B came in and divided the remaining chocolates, right? Without knowing that A ate her share, she is now again dividing the remaining chocolates into 4 parts, as she did not know that A had her share. So A and B enjoyed their shares, so that remaining chocolates are split into 4. So they enjoyed their shares and decided to put the remaining chocolates back into the box. So that's the remaining 2 parts which B has split for her sisters C and D. Now what happened? Suddenly Kami walked in, C walked in and took the box and divided again them into 4 equal parts. 3 of them ate their parts and put the last part back into their box. Now Dolly enters the room and divides the remaining chocolates into 4 equal parts. Everyone enjoyed their share and threw away the box. If we know that Kami or C ate 15 chocolates, how many chocolates did A eat? When you get questions like this, these are slightly, longer story versions, but it's always easy to solve if you start from the bottom. That is, go in the backward direction. Don't start from the start. So if you start from the start, assuming that the box had X chocolates, the problem would be you'll deal with the fractions. If you're comfortable with that, that is not a problem, right? So let me show the reverse way, then I'll also talk about the direct way, which I'm talking about fractions. Let's assume A, B, C and D are there. So let's assume when D split, right, when D split, she split into 4 equal parts X, X, X and X. Right, what will be the total? She had 4x chocolates with her D when D enters the room. She split them into X, X, X and X, and all 4 of them eat their share. So when D left, she saw 4X chocolates. What does that mean? 3 of them ate their parts and put the last part back into the box. So that means when C split them into 4 equal parts, she split them into 4X, 4X, 4X and 4X. A ate 4X, B ate 4X, C ate 4X. Then the 4X was left when D entered, right? And D entered, saw this 4X, and then she split them into X, X and X. So there was 16X chocolates when C entered, right? So she saw 16X chocolates and then she split into 4 equal parts, 4X, 4X and 4X. They ate their parts 4X, 4X, 4X. Then D entered the room, saw 4X, she split into X, X and X. So how many chocolates did C eat? 15, which is basically this part, right? X plus 4X. So 5X is 15. Okay, let me continue the story. Okay, let's talk about the situation when B entered. So C split 16X chocolates. That means she saw 16X when she entered. So what does that mean? That means 8X, 8X, 8X and 8X were there. That's how B split, right? That is 32X. So why did I write 8X, 8X? Imagine this. When C entered, B and A already ate. So she would have seen some chocolates which are split for herself and her sister D, which she didn't know. Obviously C did not know. B split 32X into 8X, 8X, 8X and 8X. So B ate her part, A ate her part. So C and D's part together in that split is 16X, which is what C saw. Right? That's why 32X were there and B split them into 8X, 8X, 8X and 8X. Now, what happened when A split? What would have A done? See, A basically had some chocolates given by her aunt. She split them into 4 parts. She ate her part, right? And the remaining 3 parts together should be equal to 32X. Is this clear? 32X by 3, 32X by 3, 32X by 3, and she would have also eaten 32X by 3. So still we have landed up with some fractions here at the end. So ideally the way you could have solved is we could have stopped the variable X here itself and then deal with the numbers from then on, which would have been easier. Why will we stop here? Because I know the clue is saying Kami ate 15 chocolates, right? When did Kami eat or C eat? When she split the part into 4 equal parts, she ate her part, and then from the remaining chocolates D came and split them again into 4 parts and C ate that also. When B split, C did not eat. When A split, C did not eat. So that means C basically eat this X plus 4X, that is 5X is 15. So what is the value of X? X is 3. That means A, B, C and D, just give me a moment, 8, 3, 3, 3 and 3 chocolates. When D split 12 chocolates, so D saw 12 chocolates, she split 3, 3, 3. That's why D ate 3, C ate 3, B ate 3 and A ate 3. So if D saw 12, what does that mean? That was D's share, right? That means A would have eaten 12, B would have eaten 12, C would have also eaten 12 and D would also have eaten 12. So that is 12, 12, 12 and 12. So A, B and C ate their part when C split, and D's part was left aside in the box, and D came and then split into 3, 3, 3 and 3. So that means C ate 12 plus 3, 15. That is satisfying this, right? Everything is fine now. Now let's go further. So if C split them into 12, 12, 12 and 12, what does that mean? How many chocolates did C split? She split 48 chocolates. So that 48 chocolates were basically left for C and D when B split. So that is 24, 24, and they would have eaten 24 and 24. So B came in, she saw 96 chocolates, okay. She split for A, B, C and D into 4 parts, 24, 24, 24. A and B ate their share 24, 24. So C's and D's share together will be 24 plus 24, 48, which is untouched. Then C entered, she saw 48 chocolates, she thought, okay, I'll split them into 4. She split it into 12, 12, 12, 12. So A, B, C ate their share, and then D's share is 12, which is kept back in the box. D entered. She thought, I'll split them into 3, 3, 3 and equal parts. That's how the chain will go. So one step before would be what? So B saw 96 chocolates. What would that be? That would be generally 32, 32 and 32 and 32. So A basically split 32, 32, 32, 32. That is what? 128 chocolates. Okay, aunt gave her 128 chocolates. She saw it. She split them into 4 parts, that is 32, 32, 32 and 32. A ate her 32 chocolates first before anyone saw it. Then B entered. She saw the remaining 32, 32, 32, 96 chocolates. She felt, I have to split them into 4 equal. That's why she split into 24, 24, 24 and 24. Then A and B ate 24 and 24 respectively. Then C entered. She saw 24 plus 24, 48 in the box. She split them into 12, 12, 12, 12. Then A, B and C ate 12, 12, 12. D entered the room. She saw this. And then she split the 12 into 3, 3, 3 and 3. Totally C ate 3 plus 12, 15. D ate 3. How many did B eat? 3 plus 12 plus 24. This is not eaten by B, right? How many did A eat? 3 plus 12 plus 24 plus 32. So that is 24 plus 12 is 36 plus 3, 39 plus 32 will be 71. So A ate 71 chocolates, right? That's how we solve this. As I said, right, we could have started off with X chocolates, right, that was split into 4 parts by A as X by 4, X by 4, X by 4. A ate X by 4, the remaining 3X by 4 was seen by B. Then she again split the 3X by 4 into 4 parts, that is 3X by 16, 3X by 16 and so on. A and B eat their part, then 6X by 16 would be the C's and D's part. Again C saw and split it. If you keep doing it, you'll get fractions, which is not that easier to solve. But if you're comfortable, you can also solve that in in that way. If you have tried and if you have doubt, you can definitely comment out and we will help you out with that method. Right, these are the example problems for the quantitative reasoning. So thank you for watching this video. If you're watching this video in the YouTube channel, make sure that you check out our full-length courses available for free at gtcube.com/store, where you'll get to watch these videos as part of the courses, where we structured the courses along with videos, concept videos and a lot of practice questions to enhance your understanding. Also, like our partners Facebook page, facebook.com/gtcube3. We're coming up with a lot of content. All the updates are shared over there. Don't miss that. Also, don't forget to subscribe to our channel so that you get all the notifications and updates whenever we upload the videos. Thank you for watching and let's meet in the next video.